Okay, here's our topic. Here's some information for you if you need it, and a QR code and some buttons for you. Okay, here is the objective. Compare and contrast them, and that is going to you may be asked to to identify them. So you're going to look at something and know what it is based upon what it looks like. All right. Now I want to go over some common examples with you that are not going to be probably on the exam, but will give you some frame of reference in the real world. A Tesla Powerwall or any rechargeable battery is an example of these types of cells. And when you're electroplating something, you're making a little electrolytic cell. Any battery that's just a 9-volt, 2-volt, whatever. That's an example of these cells. And another really great example of these cells is your car battery. All right, that lead sulfate battery in our cars. All right. So this is a little breakdown of the different types. There are two types of electrochemical cells. There's galvanaic, or also called voltaic, and the other is an electrolytic cell. Now, some examples, as I told you, of batteries, just the batteries you put in your guitar tuners, the things you put in your metronomes, the things you put in your watch, the one and done kind of batteries. Those are galvanaic cells. When you electroplate, you're really creating electrolytic cell, or when you make something go through electrolysis. That's another example of electrolytic cell. Rechargeable batteries is in the middle because when you're using it, it's acting like a galvanaic, and when you're plugging it in, it's acting like an electrolytic. All right, so let's look at the actual cells. What do they have in common? First off, what's going on in these things? The chemistry, it's a redox. You can't see it. It's the classic thing with chemistry, but it's there. These are redox reactions in both cases. Electrons are being given and taken. All right. Therefore, you need a circle for this to work, because the current's going to move around in a circular fashion. And there you can kind of see, there are my currents. Okay. Now, another thing that they have in common is these liquids. They're ionic solutions. I've got cations and I've got anions in there. All right. That's another thing that they have in common. Another thing that they have in common is they have these electrodes. All right. And these electrodes can be metal, they can be graphite, they can be anything that's conductive. All right. And on the cathode, you have reduction. That means you've got electrons being gained over here. So the electrons come here and something's gaining them. All right, so your cathode is where something's gaining electrons. Your anode is where something is losing. So the cathode's reduction and the anode is oxidation. All right. So let's just highlight their similarities. Remember, these are the chemistry here that you can't see is it's a redox reaction. You've got your electrodes. Those are those things there and there. Cathode is what's the reduction. Oxidation is the anode is the oxidation. All right. And those last two things. Now, how are they different? The main thing, well, there's two main things. You've got this. This is what is known as a salt bridge. You need a salt bridge in a galvanic cell. This one here is made of going to be made of glass. And the other thing that is different is your battery. The galvanic cells don't have a battery, whereas electrolytic cells do. And the reason being is galvanic will happen on their own, provided that it's, you've got your circuit, and they will produce current, whereas electrolytic require current. So their differences, galvanic, they've got that salt bridge. The salt bridge allows ions to move between the cells, between these two solutions. Another thing about them is that these are negative delta G's. That means they're thermodynamically favored or thermofaved because things are moving downhill, quote, so to speak. They can release energy or a current. And electrolytic, they require a battery. You need a battery. There it is. And by current, I mean like you could plug it into like a power source. That's what I mean by current. They have a positive delta G, and by that they require energy, so they're like quote unquote uphill. All right. And that's how they're different. All right. Now, so which one's which? So the Tesla Powerwall is both because it's an electrochemical cell that's either it's discharging a current through a redox reaction, and then when you recharge it, you're making it like an electrolytic cell. You're using that power source to store the energy or create an unfavorable redox reaction. It's not that it's storing energy; it's the fact that it's performing an unfavorable redox reaction. The bonus is it stores the energy later to be let go. Here I'm electroplating something. I'm taking the silver of the anode and putting it on to the spoon, which is the cathode. This is my electrolytic cell. This is electroplating. Now, this one, what is this battery? That's a galvanic cell. It's gonna, if I plug it in, I'm gonna generate a current. All right. Now, here I've got a battery going through a solution. Chances are this solution is ionic. Therefore, within this, I'm gonna have a galvanic because I've got a battery, and I'll have an electrolytic here in the solution because I'm gonna be making the bubbles like that. All right. And how about the car battery? What type of cell is that? Well, that's both. Because when it's running, when it's giving off and discharging, it's galvanic. But when it's charging, it's acting like a electrolytic. All right. And here are my sources for my images. Thank you and hope this is helpful.